Hello and welcome to Alpha Team's Learner Lecture on Buffer Overflow and Memory Stack. Our presentation will review the anatomy of a memory stack and what part it plays in a buffer overflow attack. We will analyze the effects of such attacks and discuss ways to defend or recover in the event of a catastrophic failure.
Hello, my name is Alexander, and I'm a member of Alpha Team. Today, I'd like to discuss the topic of buffer overflows with you. I'll be talking about what a buffer is, why it is important to the computer, and how a buffer overflow happens. First, let's start at the beginning and answer the question of what is a buffer. When a computer runs a program, it doesn't just run that program in a vacuum. The program needs data, and that data can be stored in a file, downloaded from the internet, or typed in via the keyboard. The program also needs a place to store that data while it is being worked on, so it puts that data into a chunk of the computer's memory, which is called a buffer. Now, we'll answer the question of how a buffer can overflow. This chunk of memory, where programs do work, is split into two parts, the heap and the stack. The stack is small, usually only about 1 megabyte in size. So, if you remember the old 3.5-inch floppy disks that could only hold about 1.44 megabytes of data, it's a little bit smaller than that. This is even true in a computer's virtual memory, where the virtual memory is stored on a computer's hard disk and is bigger than what the physical RAM has the capacity for. So because of this, it is possible to feed the stack more information than it can handle. Normally there are safeguards which can prevent this from taking place, but even so there are ways for a crafty attacker to exploit this and make it happen anyway. When the stack has more information than it can handle, this leads to the data flooding out and the computer losing control of the program that was running. Attackers can plant snippets of code, called shellcode, in the overflow to have the computer download malware, or they can even scoop up some of that overflow to see if any confidential data has leaked out. This is a common vulnerability in the C and C++ languages because they are designed to allow access to a computer's memory. Now that we know what a buffer flow is, the next question we need to ask is, why is a buffer overflow dangerous? Imagine the damage it can do to a corporation, especially a corporation that handles a person's private data, such as a bank or a social media or a search engine. So, we'll talk about why a buffer overflow is dangerous in the next section of the presentation.
Buffer overflow examples. Buffer overflow is essentially when there is more than the allotted amount of data being written. If there is a buffer overflow attack, the most common thing is for data to be overwritten in the stack and heap. Previous frame pointer, return address, and arguments of functions are some of the different types of data that's typically being overwritten. Previous frame pointer is where the code is pointed to in order to access arguments and variables for a program. Return addresses can be overwritten, causing the program to jump to an entirely new location different than where it was originally assigned to jump to. Hackers can point return address to a place where malicious code is already written and get the victim to execute their malicious code. A buffer overflow attack can also modify files, execute unwanted code, change permission settings, take control of a host, and more. If the program that caused the buffer overflow attack is privileged, the hacker now can execute malicious code using the same level of privileges and can lead to security breaches and more. They have unintended consequences, but there are plenty of options to protect yourself from such.
It is important to remember that the first step of a buffer overflow attack is to determine what specific data you want to overwrite. If the portion which is overwritten is too crucial for the device's or software's operation, then another portion to attack should be decided. It is at this point that the software that will be executed should be developed, because it is impossible for a buffer overflow attack to be a one-size-fits-all for different devices or software. You also need to know ahead of time how you will send your code to start the buffer overflow in the first place. This can be done through an automatic flash drive, a piece of insecure software already on the device, or in the form of a data entry. At this point, one can start the attack. There are a few things to remember before going straight into the attack. First, have the buffer overflow program tested in the closest similarity to what is being reached, as it may accidentally cause a crash or override something that wasn't targeted. Also, make sure that the program will function as intended for the specific architecture of the software, if relevant. Different software versions or variants may have differing vulnerabilities.
Let's look at techniques used to protect against buffer overflow. Patches. Patches are software updates intended to remove a vulnerability or defects in software or provide new features or functionality for it. Updates. An update is a service pack or patch that improves the reliability, security, or attractiveness of an OS. The most reliable source of operating system updates is the OS manufacturer. Canary tests are software automated tests done in small groups after they pass a sandbox test without affecting applications in which they run. Bounds checking is validation and verification of code to ensure it will work properly by the end user and is free of defects. Debugging. GDB and GNU are debuggers that allow the programmer to examine the program internally while running and executing in real time to make changes as needed. Address Space Layout Randomize, other known as ASLR, is just that it randomizes the address at load time. It is one of the most widely used defense mechanisms to prevent attacks today, backing all modern operating systems. I encourage you in your free time to research GDB and GNU debuggers more in depth. Some of the precautionary measures include the following. Backup site is a site in which to relocate as a recovery site in the event of a disaster. There are 3 different types: cold, warm, and hot. A hot site being the most expensive because it is a mirror image of the host site and can restore operations in a matter of hours. Backups. Backing up software and having spare hardware devices are vital to network availability. An organization needs to have the capability to restore data if drives, switches, or routers fail in the instance of a disaster or software corruption. Worst case scenario, an organization will have to wipe and restart. Disaster recovery plans are developed and implemented as a plan to be resilient and restore capabilities. In order to produce a sound product, first we need to understand what does the buffer overflow gain access to or want to attack. Then we can build our defense mechanism. The NIST framework is the industry standard that provides and lays out the fundamentals for establishing the proper procedures. These procedures are to be utilized by organizations to assess their cybersecurity risk and implement measures to identify, protect, detect, respond, and recover.
What is a famous or infamous buffer overflow attack that has occurred over the past year? When did one of the first buffer overflow attacks occur? What type of damages could a buffer overflow attack cause to a large corporation? How could it be prevented?